All right, good afternoon, everyone. Welcome to the 1883 Speaker Series. My name is Mike Wozniak, and I serve as the Director of the Department of Leadership Development. Over the next 18 minutes and 83 seconds, we'll explore a new lesson in leadership and gain valuable insights to support both our personal and professional growth. For today's speaker, please join me in welcoming the Dean of UND's College of Engineering and Mines, Dr. Ryan Adams.
Good afternoon, everyone. I want to start with an exercise. I promise there won't be any grading, but I do want you to go through a little bit of thought process with me. Think for a moment about any problem, challenge, opportunity that's big, long-term, and if solved, it would change the world. You got it in your head? Pick one. I don't care, just pick one. Now, look at that in your mind and think. Can that problem be solved by a single discipline, academic discipline, by itself? I would argue that any major problem that's long-term, that affects a lot of different people and could change the world, simply cannot be solved by a single discipline. It must be solved by groups, large groups, teams, and especially collaboration. We like to fantasize, maybe that's not a good word, but we like to romanticize about the lone genius. Right? There are a lot of stories in history about a lone genius, one person that just thinks through a problem, does some experiments, and says, this is a new idea. And if you look through history, Albert Einstein is one such person that often is talked about. He was in his early 20s, working for the Swiss Patent Office. He was new to the position, had trouble getting the position, and yet, while he was there, he came up with the theory of special relativity. He came up with or discovered that there is an equivalence between matter and energy. That is huge, right? He does not have a position of prominence. He's kind of off in the corner in the Swiss Patent Office, and yet he came up with these amazing, amazing discoveries. If you go back a little bit further, you have James Clerk Maxwell. James Clerk Maxwell had an estate in rural Scotland. He was an incredibly intelligent person, but he wasn't an experimentalist, so he spent a lot of time on that rural estate thinking through several thought experiments, and eventually he came up with what we now know as electromagnetism. That led to all of wireless communication, all of the electronics revolution we've seen over the last century or so. Incredible contribution, despite the fact that he lived in this very rural estate. If we go further back in history, we find Sir Isaac Newton, who is thought to have been in isolation, discovering things like calculus and several of the fundamental theories of physics. Again, in isolation. Now, these are great romantic stories, and they give us a lot of pride in humanity, and they give us a lot of hope for what we could accomplish. The problem is they're all wrong. Not one of these people did anything in isolation. Albert Einstein famously worked collaboratively with everyone he could throughout his entire life. And even during that time in the Swiss Patent Office, he was a PhD student working for a PhD advisor with academic colleagues the entire time. If you go back to James Clerk Maxwell, he built his equations on the shoulders of Michael Faraday, Ampere, Gauss, and others. Michael Faraday in particular was a close friend of his. They worked very closely together until Maxwell added one term that became Maxwell's equations. If you go back to Newton, he was a faculty member in England, and he had all kinds of colleagues, students, and others that he bounced ideas off that eventually led to what we now know of as calculus and the other discoveries he made. None of them acted in isolation. All of them contributed to the future through collaboration. What we're going to talk about today is collaborating and the importance of it and how it impacts the world. Solutions require teams. So I'm going to give you a couple of stories. The first story is microwave ovens. They're ubiquitous. We have several in the building here. I'm sure you have one in your home. There are some in offices all around the world. They are ubiquitous. They were created, the first marketed microwave oven came out in 1947. It was shockingly expensive. It was very difficult to build. It was built based on the radar analysis and development that was done during World War II. So someone came out with it, they tried to sell it, and no one wanted it. They couldn't find a market. Eventually, by the late 1970s, the costs came down, the product became high enough quality, and customers started to become interested. And so finally, in the late 70s, it became a product, and throughout the 80s and beyond, it became ubiquitous around the world. We needed a team to turn that viable product into something of value. And that team was engineers and scientists, but it was also marketing folks, it was economists, it was people that were good at manufacturing, and so on and so forth. All was necessary, all needed to happen, and it took 30 years for that to happen for that specific product. I remember, by the way, when I was young, my parents got our first microwave oven from our grandparents for Christmas. And when we opened it up, my dad took one look at that. He's an electrical engineer, by the way. He looked at it and he said, "What on earth is this for? What a waste of money," right? I already have a stove, I already have an oven, what do I need this for? About 30 seconds later, someone put a frozen burrito in there and we realized how valuable it truly was. But initially, there was customer pushback. People didn't know what it was good for. So again, there's a team that is necessary to make that happen. In the case of the microwave oven, it took 30 years to put that team together. The reason why we need those teams is because the problems we have today, even relatively simple problems, are collections of systems. If you go back to Milton Friedman, the great economist, he described it in the form of a pencil. He said a basic wooden graphite pencil there's no one person on earth that knows all the steps to make a pencil. Even though they're cheap, you can buy them for pennies. No one person knows how. If you think through it, you need a whole team of experts that know how to harvest trees, turn them into the wood products necessary to make the wood. You need another team to pull the minerals out of the ground, turn that into metal for the ring. You need other people that know how to handle the rubber for the eraser, and so on. All of those require expertise. All of those require working together to create a very, very simple product, a pencil. So if you think through it, each of those products, each of those steps were themselves a complex system. Each of those needed expertise, and each of those needed to work together with their partners until they created something that has value. Innovation is another word that we often talk about when we look at new things and solving these problems. Innovation is a great word. How often can we apply that word innovation within the confines of a single academic discipline alone? I would argue it's very, very rare. Innovation happens at the boundaries. Innovation happens where engineering meets medicine, or business and economics meets science, or whatever. It happens at the boundaries. Where those different disciplines touch, we create innovative ideas. On that note, we have a great medical school here. We are teaching some amazing medical practitioners and scientists. We have some great faculty that are doing some great things for the human body and the human condition. One of the disciplines that we teach up there and expose our students to is medical imaging. This is an interesting one to me because medical imaging as a discipline has only been around for about 100 years or so. It wasn't until the 1890s that we discovered that you can irradiate with x-rays a human hand and see the bone structure inside. And that led eventually to x-ray images and so on and so forth. From there, we developed CAT scans, we have MRIs, we have ultrasound machines, all down the line. We have a full team of imagers that know what to do to detect disease and problems. Can you imagine going to the doctor saying, "I've been injured, I need to know what to do," and the doctor said, "Well, I don't know what to say, it's probably broken, it might not be, but do this," right? Or now we go in, they take an x-ray, they see, "Yep, it's broken here, it's broken that way, let's straighten it out and get it casted so that it can heal correctly." We have that because we have medical imaging. Medical imaging is a combination of physics, engineering, medical professionals, and a whole host of other disciplines that all came together, again, collaborated to create something new that we now take for granted. There are so many of these examples out there. Now, if you look at industry, we are academics, right? I'm in this department, you're in that department. Everyone is kind of in their field, and we don't often think of ourselves in terms of the broader group. But if you go into industry, this is how industry works. I'll give you one great example in industry that's just more of a commercial venture. The Apple iPhone. How many people here remember when the iPhone hit the market? It changed everything, didn't it? Cell phones before that were designed by engineers. They were very basic, they were very clunky. They did the job. You could talk on the phone, you could text. If you wanted to waste all of that time hitting the number pads multiple times to get a text out the door. In fact, it was so awkward and clunky that it changed the way we write and speak, because it just took too long to spell out a long word. You narrow it down to LOL, meaning I laughed out loud, right? Because it just takes too long. All of that happened, and all of us that were a little bit older got a little frustrated with the young generation because can't they just write normally? But it was driven by the technology. So Apple came together and they said, we can do better, we have the technology, but we also need to know what our customers want. And we need to know how to give our customers not just a product they can use, but an experience. So Apple got together the engineers, scientists, and others. They got the marketing people, the artists, et cetera, everyone, salespeople, all together, and they said, let's create something great. They went all the way to the point of not just creating the actual phone itself, but they completely revolutionized how we package electronics. You remember before that, packaging was just an afterthought. It just is there to protect the product until it gets in the hands of the customer. But when you open an Apple product, it feels like a luxury item. Everything was thought out. Everything is polished. Everything is finished. It changed everything. And of course, now you have basically a computer in your hand. You don't need to text in that awkward and clumsy way. You can send email on your phone. You can search the web. You can do all kinds of amazing things. It was an incredible contribution. Now, how did they do it? Again, quick reminder. They took teams of people with great expertise in their field, got them together, and helped them work together to solve an interesting problem and exploit an interesting opportunity. Now, what is collaboration? I think a lot of people misunderstand. We like to say that collaboration is getting a bunch of people in the same room. That is important to collaboration, but it's not enough. As mathematicians would say, it's a necessary condition, it's not a sufficient condition. You need more than that. Is it taking a problem like the iPhone and saying, well, this part you work on, and this part you work on, and this part I'll work on, and we'll all do our things, and then at the end of the day, I'll email it to you? Is that collaboration? I would argue no. That's coordination. Collaboration consists of us actually having a conversation and actually talking through the problem from each and every perspective. There's a problem there, though. Some phrases and some words have very specific meaning in different disciplines. Let me give you an example. The phrase, prove it. What does that mean to you, right? If you're a mathematician, you might think, well, that means I've got to go through deductive reasoning to find a logical conclusion. If you're an engineer, you say, well, I'm going to prove it by building it and showing that it works. Other people may look at that and say, well, are you making reference to Missouri, the show me state? What do you mean by prove it, right? Everyone has a different interpretation of that very, very simple and short phrase. What does it mean to you? What does it mean to me? Oftentimes, when we communicate and we try to collaborate, we get a little argumentative, not because we disagree, but because we misunderstand. So communication is one of the absolute key components of collaboration. We have to learn how to communicate, and we have to learn how to communicate in a way that our audience can understand, and we have to have patience with each other so that if I don't understand, I have the discipline and the drive to say, I didn't understand, can we work this out? We have to give each other grace. We have to have a little humility. We have to understand I don't understand everything. I may not even be the smartest person in the room, but I know that someone understands it. And together we can solve this big, giant problem. Now, what if you're not communicating well? I'm gonna pull out Apple again. I've given them a compliment. Now I'm gonna share a little bit of embarrassment on the iPhone 4. How many people here remember Antenna Gate? Does that ring bells? It was a fascinating time. I'm an antenna engineer, so of course it was very, very relevant to me. In 2010, Apple came out with their iPhone 4. The iPhone 4 was a revolutionary change from their design, and what they did is they integrated a bunch of antennas along the outside of the case. It was very polished, it looked great, and sitting in the lab, it worked fantastically well. However, when you pick up the phone, your hand ended up shorting out the antennas and they stopped working. So maybe the phone rang on the table, but the minute you picked it up, it loses connection to the cell tower, and now you no longer have a connection. There's no point in it. Everyone was angry. It got sold, it got marketed, people tried to use it, and it hit all the national news. It was a terrible embarrassment for Apple. They ended up having to send out cases for every single iPhone 4 that they sold that covered that up so that it didn't happen anymore when people used it. It was a very small thing that cost them a lot in market share and other things. So what happened here? How did this go wrong? Apple got in the habit of coordinating, not collaborating. The antenna engineers went off and did their thing, and isn't this great and exciting? The marketers went off and did their thing, isn't this great and exciting? Other engineers and people did their various parts. It looked great, but it didn't work. At the end of the day, it failed because they did not actually communicate. They didn't actually collaborate. They just coordinated. So things can go wrong pretty quickly, even when you have a lot of success. So what does that mean for STEM? And that's really what I want to focus on. We have our STEM students, science, technology, engineering, and math. It is absolutely critically important that our students in all disciplines, but especially STEM, have a depth of understanding. Nothing about what I'm saying here suggests we should lower any standards in terms of technical expertise. We need electrical engineers to fully understand the depth of their skill set and their discipline. We need mechanical engineers to understand the depth of their discipline. Same thing for mathematicians, physicists, etc. They need to have a depth of understanding. Researchers also, we have some amazing researchers on campus. They need to have a depth of understanding in their field. The question that I ask you is, why do they need that depth of understanding? And the answer is this. We are preparing our students to go off into industry, to go off into research and government labs, and do a variety of things. But in every single case, they will be part of a team of multidisciplinary people, and they need to have the expertise so that they can contribute effectively to that team. Regardless of what the team is, they will be part of it. No engineer, no physicist or mathematician goes into industry or a government lab and just works in their own little narrow niche and doesn't work with other people. Everyone works with other people. So when we talk about the depth of understanding, it's absolutely critical that they contribute to the team. But if we don't give our students the opportunity to learn how to communicate with people that are not with their background, we've missed an incredible opportunity. So what I'm asking for us to do is to think about STEM education with the lens of finishing the job. Getting our students to the point where they can actually explain something very technical and deep to someone that does not have the same background as them. Enough so that you can communicate, so that we can actually collaborate, so that we can solve the world's most compelling and pressing problems. Without that last mile, without that last step, our students will struggle, industry will struggle, and the problems that we face in society and the world will not be solved. So that's what I ask. Now, practically, what does that mean? Well, let me talk to some students for a minute. As a student, what I suggest is that you take a class or two or engage in a process whereby you are working with students in other disciplines. There are lots of competitive teams. There are lots of student clubs. There are opportunities to take a weightlifting class or something, an exercise class where you're meeting students from everywhere else. Talk to them. Learn how they think a little bit. Learn how to communicate and share what you're learning in a way that they can understand. Take advantage of those opportunities. Get on multidisciplinary teams in your programs if you can. Learn to communicate across those boundaries. I'm not suggesting you reduce your technical acumen. Absolutely keep that strong. But add that one last piece where you can communicate with people that don't think the way you do, that don't see the world the way you do, and together you can solve some incredible problems. That's the students. For the faculty, I ask that you introduce some things that students can do, opportunities for them to think a little outside the box. Get a little closer to those boundaries. Maybe give a problem that informs the student in a way that you need for your class, but maybe it's a medical-related problem, or maybe it's a computing problem, or maybe it's a business problem, or something like that. Get the students thinking a little outside the box so that they have that round education and they'll be successful in industry. For leaders, leadership is incredibly important, that you find time and opportunities for collaboration and protect those times. Get multidisciplinary teams together to solve these problems and protect it religiously. Make sure it happens. And then the last mile is figuring out how to prevent arguments, because that's what's going to happen, right? When people try to communicate and they're talking over each other, it can easily turn into a negative thing. So we as leaders need to figure out how to engage in these conversations in a safe, professional, and respectful way. If we can do those things among this group, think of the problems we can solve. The future does not care about what your discipline is. The future does not care what venue you publish in or any of that. The future cares about one thing, and that is, can you work together? If the answer is yes, the future belongs to you. Thank you.
All right. Thank you, Dr. Adams. Thanks to all of you for attending today. Join us on February 11th at 2:30 when we welcome the Interim Dean of the Nistler College of Business and Public Administration, Dr. Patrick O'Neill. Have a great rest of your week.